Hello everyone, I hope you guys are doing well. Today I am going to discuss the another form of capital X to find out the particular integration. So in case to find out the particular integration, or if your capital X is of the form like e to the power x into v, okay, where v is the function of x only, where v is the function of x, okay. It may be trigonometric and it may be algebraic, it may be anything hyperbolic, okay. So how do we find the particular integration for such type of capital X if our capital X is of the form? What about the short trick? So we have the very simple funda about it. So just our pi will be represented as 1 upon f of d e to the power x into v. So you can take e to the power ax outside and replacing d of f of d by d plus a into v, okay. And then after that solve it accordingly, as v is your cos x or sin x or algebraic, and we have the complete theory about that in the previous lecture. Now come on, to understand this I would love to introduce the question, and question is: solve the given differential equation, that is d square minus 2d plus 1 is equals to x square e to the power 3x. Now how we will solve? Solution is quite simple. Just first of all, you need to find the complementary function. To decide the complementary function, you need to find the auxiliary equations. So for the auxiliary equation, you need to write m in place of d, so it will be m square minus 2m plus 1 is equals to 0. And to find the CF, we need to find the root of this. Obviously it is written as m minus 1 whole square is equals to 0. So you will have two roots here. The value of m are 1, 1, which are the repeated roots. So complementary function will be decided as c1 plus c2x e to the power x, okay. It is your CF, so it is quite easy to calculate. Now we need to find the particular integral. To find the particular integral, we need to solve 1 upon d square, or you can write it d minus 1 whole square, d minus 1 whole square x square e to the power 3x. So you can take outside e to the power ax, okay, e to the power x by replacing d with d plus a. So here replace, what about the a we have 3, so a is equals to 3. So we need to replace d with d plus 3 minus 1 whole square, and you can take e to the power 3x outside into x square. So what about the resultant? E to the power 3x 1 upon d plus 2 whole square into x square, okay. And which is a binomial form, sorry, which is a x to the power m form, or polynomial form. So to solve this, we need to convert it into the 1 plus phi of d form by taking the lowest degree term common, lowest degree term outside, okay. That is, you can take lowest degree term means 2 outside, that is 2 to the power 2 is outside. Now 1 plus d by 2 to the power 2 x square. Now you can write it as e to the power 3x by 4, and you can write this in numerator as 1 plus d by 2 to the power minus 2 x square. So it is e to the power 3x by 4. Now you can apply here the formula, binomial formula, that is 1 plus nx. So 1 plus, what about the n value is minus 2. So 1 plus nx, x is d by 2, okay, and then plus n minus 1. So minus 2, and minus 2 minus 1, that is minus 3 whole divided by 2 factorial. and that nn minus 1 nn minus 1 upon 2 factorial into x square, okay, sorry, d square, and d square by 4, because we have d by 2 d, so it will be written as d square by 4. And similarly for the next term you will have d to the power 3, so which will make this term 0, because d to the power 3 into x square will be 0. So all the rest term here calculated will as zeros, okay. So now what about the resultant e to the power 3x by 4? You can write it as 1 minus 2 will cancel out, so 1 minus d, and minus minus plus, and 2 factorial is cancelled out by 2, so you can write here plus 3 by 4 d square, okay, d square, and then whatever, okay. So you are here with as x square, okay. So now multiply x square inside, so we will get e to the power 3x by 4 x square and minus 2x, d into x square means 2x, derivative of x square, so plus 3 by 4, okay, and double derivative of x square is 2, so and rest of the terms are zeros. So you will have here e to the power 3x, it is, you can take 2 as an LCM, so 4 into 2 is 8, and it will be 2x square minus 4x and then plus 3, which is your pi. So what about the general solution? So the general solution will be written as c1 plus c2x and e to the power x, and what about pi? E to the power 3x whole divided by 8 and 2x square minus 4x then plus 3, okay, which is your general solution. So you will solve such type of questions very simply, okay. Now we deal the another question to support this theory. Come on, we have the next question is find the or solve d to the power 3, okay, and minus 3d minus 2 y is equals to 540, okay, x to the power 3 and e to the power minus x, okay. Now we need to solve this question. So first of all we need to find the complementary functions. So to decide the complementary function we need to calculate the auxiliary equation first, okay. What about the auxiliary equation? So auxiliary equation is m to the power 3 minus 3m and minus 2 is equals to 0, which is your auxiliary equation. Now here we need to find the roots of this polynomial, this auxiliary equation. So to find the root, first root we will decide with hidden trial, okay. If you write here m equals to minus 1, so minus 1 to the power 3 and 3 into minus 1 and minus 2. What about this? So it will be as minus 1 and plus 3 and minus 2, so it is 0. So m equals to minus 1 is a root, means m equals to minus 1 is a root of this, means m plus 1 is a factor of this, m plus 1 is a factor of this polynomial. So now divide it with this factor. I am dividing here, that is m to the power 3 minus 3 m minus 2 whole divided by m plus 1, okay. So m square and plus m to the power 3, okay, m to the power 3 and plus m square. So what about the resultant? These are cancelled out, so minus m square and minus 3m. So now to get minus m square we multiply by minus m with this, so you will get minus m square and minus m here. So on dividing it will be cancelled out, so you will get here minus 2m and then minus 2m, okay, and then minus 2. So now you multiply here by minus 2. So minus 2. So you will get here minus 2m and then minus 2. So on subtracting, all these are 0. So we have m plus 1 and m square minus m minus 2 is equals to 0. Now come on, we need to solve this with the middle term. You can solve it with the middle term also. Yani m square minus 2 minus 1 m and minus 2, okay, is equals to 0. So m plus 1 and m square minus 2m plus m minus 2 is equals to 0. So we are here 3 factor, m plus 1, m minus 2 and m plus 1 again, okay. So we are here the value of m, 3 value of m are there, that is 2 comma minus 1 and minus 1. 2 are repeating and 1 is distinct. So what about the complementary function? So it will be decided at c1 e to the power 2x and plus c2 plus c3x e to the power minus x. Or you can write it as also c1 plus c2x e to the power minus x and plus c3 e to the power 2x. It's up to you, okay. Now what about the particular integration? So to find the particular integration, you need to calculate 540 x to the power 3 e to the power minus x and 1 upon d to the power 3 minus 3d minus 2, okay. Now you can write it as 540, you can take e to the power outside e to the power minus x, replacing d by d minus 1. So d minus 1 to the power 3, okay. Or I would love to write it in the form like d minus 2 and d plus 1 whole square, okay, e to the x to the power 3 and e to the power minus x. So it will be easy now to calculate it, e to the power minus x, just replace d by d minus 1, okay, d by d minus 1. So it will be d minus 1 plus 1 square and x to the power 3. So now we are here 540 e to the power minus x and 1 upon d square and d minus 3 x square, x to the power 3, okay. So now come on, we need to solve it. So for the solution for this, we will write 540 e to the power minus x 1 upon d square and just take the lowest degree term common outside, okay, that is minus 3. So you will get here 1 and 1 minus d by 3, right, and minus 1 x to the power 3, okay. So minus and 180, okay, e to the power minus x 1 upon d square, right. And now you will expand it by the binomial expansion, okay, 1 plus x and plus x square, okay, and then plus x to the power 3 means, okay, and there is no need to expand it x to the power 4 because d to the power 4 x to the power 3 will contribute 0 and rest of the term will contribute 0. So there is no need to write them, okay. So e to the power minus x 1 upon d square and you will write here x to the power 3 and plus d 1 by 3 into 3x square, right, and then plus 1 by 9 means double derivative of this means 3 into 2 into x, right, double derivative of the 3 into 2 into x. Then triple derivative means 1 upon 27 and 3 into 2 into 1, okay. Now what about the resultant minus 180 e to the power minus x 1 upon d square and we have x to the power 3, okay, and we have plus x square and we have plus it is 2 by 3 x, right? And we have here 1 2 by 9, okay, 2 by 9, okay, 2 by 9. Now come on, 1 upon d square means what? 1 upon d square means nothing but the integration, okay? 1 upon okay, 1 upon d means first integration, and 1 upon d square means double integration, right? So first 180 to the power minus 6. Now 1 upon d, come on, integrate it. X to the power 4 by 4 plus x to the power 3 by 3, and then plus 2 by 3 and x square by 2, okay, and then plus 2x by 9, right? Now come on, again integrate it, e to the power minus 6. So what about this? X to the power 5 upon 5 into 4, that is 20, and then plus x to the power 4 upon 12, and then plus 1 by 3 and x to the power 3 by 9, and then plus x square by 9, okay? So you can take 180 LCM in the denominator. The LCM of these terms is 180, obviously. So just you can write it 9 x to the power 5, okay, and plus how much times it will be, I think it is 15 times, okay, x to the power 4, 180 divided by 12, okay, right, it is 15x to the power 4, and plus x to the power 3, okay, it will be 20x to the power 3, okay, and then plus 20x square, right? It is cancelled out. So we have minus e to the power minus x and 9x to the power 5 and plus 15x to the power 4 and plus 20x to the power 3 and plus 20x square, okay, which is your pi. Now combine your complementary function with pi, you will get the general solution, okay? So guys, we have the very easy steps to solve all these types of the form, and we have the another format also. We may have the question as I'm introducing some other question in the form of sin x. Now question is solve d square plus 3d and plus d y is equals to e to the power 2x into sin x, okay? So what about this? So to solve this, first we need to find the complementary function. So what about the complementary functions? We need to calculate the auxiliary equation, and the auxiliary equation will be calculated m square plus 3m and plus m. M square, I'm sorry guys, here should be d square plus 3d plus 2. It is 2, okay? So it is 2 equals to 0. Obviously you can middle term split here, m square and plus 2m plus m and then plus 2 is equals to 0. So you can take m common here, m plus 2, and you can take 1 common here, m plus 2. So we have to factor here, m plus 2 or m plus 1. Now what about the values of m? So we have two values of m, that is minus 1 and minus 2. So we have the complementary function as c1 e to the power minus x and plus c2 e to the power minus 2x. It is your complementary function. Now for the particular integral, now we find 1 upon d square plus 3d plus 2 e to the power 2x and sin x, okay? Or you can write it as you can e to the power 2x, and you can replace d by d plus 2, so d plus 2 whole square, and then plus 3 d plus 2, right, d plus 2 and then plus 2 and then sin x. Okay, now you can simplify it as e to the power 2x 1 upon d square, right, and you can write it as plus 4 and then plus 4d, okay, and then plus 3d and then plus 6 and then plus plus 2, okay, sin x. So after the simplification, you can find here, you will replace here because you have the trigonometric function, so d square will be replaced by negative of the negative a square with negative sign. Okay, so a is value 1 here, so d square will be replaced by minus 1 square. Okay, minus 1 square and 4 plus 6 10 and then plus 12, right, and then 4d and plus 3d, that is 7d. Okay, and it is sin x. So you can write it as e to the power 2x 1 upon e to the power 2x, that is 11 plus 7d sin x. Okay, now obviously we have the trigonometric function here. Now we try to make it here d square, so just multiply by its conjugate in the numerator and denominator. Okay, so you can multiply in the numerator as 7d minus 11, okay, and in the denominator also, so you will get 49 d square and minus 121, 11 square is 121 sin x. Now replace d square with a square with negative sign, so e to the power 2x 7d minus 11 and 49 multiply by a square means 1 square with negative sign, so it is minus 11 sin x. What about the resultant? So you will get as minus 49 and minus 11, that is 60. Okay, that is minus 60, so it is minus 60 in the denominator, and it is 7d minus 11 and sin x. Now come on, minus 1 upon 60 e to the power 2x and 7. What about the derivative of sin x? That is cos x. Okay, and then minus 11 sin x. Okay, which is your pi. Just combine your complementary function and the particular integration, you will find the general solution. So guys, there are number of examples and number of questions here to solve such type of questions. So I hope you guys have understood, okay, have understood clearly my point. And in this with this factor or with this format of capital X, we complete our first order higher order differential equation with constant coefficient. Okay, next we deal with higher order differential equation with variable coefficient, and I request everyone to like, share, comment and subscribe the channel. See you in the next class. Thank you very much.